Alamo.alicum. Welcome back to our channel, Digital Future AI School. Kindly subscribe our channel, like and share with friends. And this is the episode 28 of Book AI Agent Makers, written by Mr. Zahir Ahmad Mir. Okay, let's unpack this. The source material we have today it's not about the philosophy of AI or, the latest big language model.
At all.
It's a blueprint. It's a blueprint for what looks like the future of automated labor.
That's a great way to put it.
What you've sent us here is Appendix R from the book AI Agent Makers, and it's an incredibly detailed inventory of advanced executable AI systems.
Precisely. And the key words there are multi-agent ecosystems. We're not talking about a single chatbot doing one task, which is, frankly, where most people are still playing with AI.
Right, like asking it to write an email or something.
Exactly. We are looking at entire teams. Think of them as mini AI organizations, all designed to collaborate, to communicate, and to complete these really complex multi-step workflows.
And in some very high-stakes fields, I'm seeing law, education, business, even medicine here.
Yes, these systems are designed to replace entire functional workflows, not just, one small step in a much bigger process.
So that really defines our mission for this deep dive. Our goal is to get into the architecture of these 20 systems. We need to explore how this idea of specialization, giving each AI agent one very specific job, how that drives true high-quality automation. We want to give you, the learner, a complete shortcut to understanding what feels like the absolute cutting edge of AI implementation. It's this move from single generic agents to these structured, reliable, what the book calls production-grade ecosystems.
Ecosystems that you can, in theory, build and deploy right now. We're really dissecting the operational schematics for the future of white-collar work. It's a purely architectural view of automation.
An architectural view. I like that frame. Okay, so before we jump into the legal briefs and the startup pitch decks, let's start with the basics. What makes these systems so unique? What makes them production-grade?
Well, what's fascinating here is the level of engineering discipline that's applied to each one. These aren't just, clever prompts that give you a different result every time.
Right, they're not unpredictable.
No. The source really emphasizes that they are production grade. And that means they're built for repeatable, reliable execution in a real-world scenario. They're ready for deployment in sophisticated frameworks like Crew AI or Autogen or LaneChain. Reliability is the absolute key differentiator.
So when you say production grade, we're talking about the difference between, say, a prototype you might build in an afternoon versus a finished system that a huge company could actually rely on day in and day out.
Exactly. And that reliability, it comes from structure, not just from raw computational power.
So a single prompt is just an experiment.
It's an experiment. A production-grade system is a fully structured team. Usually, it's somewhere between 3 and 7 highly specialized agents where the entire process is codified. Every single one of these blueprints confirms this by including 8 critical components for deployment.
8 components. Okay, walk us through those, because it sounds like they define the structure for this entire deep dive. This is what you need to build before you can even launch one of these AI teams.
Certainly. So first, you have the system name and purpose use case. It's a clear, unambiguous mission statement.
Okay, simple enough.
Second, a defined list of the agents included, each with its own hyper-specialized role. Third, and this is probably the most critical part, are the communication rules.
The communication rules, so how the agents talk to each other.
Yes, but it's more than that. It dictates the entire sequencing of the work, who talks to whom, when they talk, and maybe most importantly, what format that information has to be in.
So it's not just a free-for-all brainstorming session between a bunch of AIs.
Not at all.
It's a strict assembly line with quality checkpoints built in. If Agent A sends, sloppy output, then Agent B is just going to fail.
It is a digital assembly line. Precisely. The fourth component is the workflow, the exact step-by-step procedure the agents have to follow. Fifth is the tools allowed.
And tools are what connect the AI's brain to the real world, right? So it can actually do things like search a legal database or send an email.
Exactly. It's what grounds the AI in reality. Sixth is the defined output produced, what the final result should look like. Often it's in a really strict format, like a JSON file or a PDF brief.
I see. And the last two?
The seventh and eighth are the sample commands and configuration parameters. This just standardizes the input so the system is easy to activate and responds predictably every single time. This whole level of specification is what makes them robust.
This brings up the big question then, the one that every architect of these systems has to face. Why all the specialization? Why go through the effort of building a 5-agent team when you could just ask one really powerful model like a top-tier GPT-4 to do the whole job?
It's a classic trade-off, performance versus reliability. A general-purpose model, when you ask it to do a really complex, multifaceted task like draft a legal brief and analyze precedents and find contradictions all at once.
You're going to get confused.
It often suffers from context switching, or what we call hallucination, because it's trying to wear too many hats at the same time. The sheer volume of instructions just overwhelms its context window.
So the agent team basically acts as a massive context splitter.
That is the perfect way to frame it. By forcing specialization, giving Agent A the research task, Agent B the analysis task, and Agent C the quality control task, you dramatically constrain the scope of potential failure for each individual part.
Because each agent has a much smaller, more focused job.
A single, well-defined objective. It often uses a highly optimized, much smaller prompt template that's tailored only to that one task. This modular approach ensures far greater accuracy, much lower rates of hallucination, and it forces adherence to the workflow. The cost of running 5 models is massively outweighed by the gain in quality assurance.
Specialization drives reliability.
That's the bottom line.
That's the lens we need to view all 20 of these blueprints through. Okay, let's start with what might be the highest stakes, most procedure-driven area of all. The legal domain. So we're moving now into Section 2, diving into the legal multi-agent systems. The source categorizes these as R.1, and right away there are 5 distinct setups, which tells me that the law isn't one single automatable task.
Oh, not at all. It's a series of hyper-specific, highly procedural workflows that benefit immensely from this kind of agent partitioning. Legal work is almost ideal for this because it relies on documented precedent, interpreting fixed statutes. It has all the ingredients for rule-based, quality-controlled AI collaboration.
Let's put a spotlight on the flagship system here, R1.1, the High Court Case Preparation Multi-Agent System. This one uses 5 specialized agents to prepare, the whole package. Case briefs, arguments, evidence charts, even oral submissions.
This is basically automating the work of an entire junior litigation team.
It seems like it.
What's remarkable is that it perfectly mirrors the actual structure of a major law firm, where tasks are segmented for efficiency and oversight. It's never just one lawyer doing everything. It's a sequential, collaborative process.
And the workflow here looks like the gold standard for that sequential communication you were talking about. It starts with uploading the basic documents, a prior judgment, maybe, and then it just proceeds linearly through the 5 agents.
Each one refining and validating the work of the one before it.
So the process starts with the research agent. Its job is purely foundational, right? It just extracts the undisputed facts, defines the issues, and finds the ratio decidendi?
The ratio decidendi, the legal reasoning behind a previous decision that's being challenged. And you're right, its output has to be clean, structured data. No opinions, just facts.
Okay, so once that structured factual foundation is laid down, the output goes straight to the statute agent.
Correct. And the statute agent operates only on the facts that Agent 1 provided. It then applies the relevant constitutional articles, statutes, and legal doctrines. This rigid separation is key. It ensures that interpreting the law is totally separate from summarizing the facts.
It reduces the cognitive burden on each step.
Precisely.
Now, here's where the engineering really shows its value. This is the part that I think is the core innovation. The third agent is the contradiction agent. And its sole purpose isn't to create anything. It's for critical review. It's designed to detect misreading, non-reading, internal contradictions, or legal inconsistencies between what the research agent found and how the statute agent applied the law.
That contradiction agent is the non-negotiable part. It's the mechanism for achieving production-grade quality in legal work. It acts as a tireless internal peer reviewer. It's not just passively reading the output. It might run a quick targeted search on its own to see if a chosen statute has been recently amended, for example.
So how does it actually execute that critique? Is it just looking for keywords, or is it a specialized model that's been trained on logical fallacies or something?
It's highly specialized. It's not looking for creative solutions. It's hunting for errors. It's likely prompted with a very specific, rigid rubric, something like compare output A to output B, and generate a confidence score of internal consistency based on these 5 criteria. If the score is below 90%, flag the conflict and reference the specific conflicting data point.
So it forces the system to self-correct. It stops the whole process from building a flawed argument on a faulty premise.
It is the gatekeeper.
And only once the contradiction agent signs off Then the work moves to the drafting agent to write the formal arguments.
Uh-huh.
And finally, a fifth agent, the QC agent quality control, which finalizes accuracy, tone, citation format, all the procedural stuff.
And the final output is, well, it's everything. A full legal brief, oral submissions, grounds for appeal. This system automates probably 80 to 90% of the crucial, time-consuming foundational work that junior associates and paralegals do. It standardizes high-stakes document production.
An environment where, error is just not acceptable. We should probably quickly review the other four systems in this legal stack because they really highlight how you can partition and automate these hyper-specific functions.
Absolutely.
Okay, so R.1.2 is the multi-agent system for writ petitions. This uses 4 agents: facts, grounds, precedent, and petition drafting. The focus seems entirely procedural.
It is. The specialization here is laser focus on the specific, often very rigid requirements of a writ petition. That's a high-stakes document that demands immediate relief. So the agents are tasked only with compiling the components needed to persuade a court to take the case right away.
I find R.1.3, the contract lifecycle multi-agent system, to be profoundly important for any business. It has 5 agents: requirements, drafting, risk, negotiation points, and a final contract agent. The critical one here seems to be that risk agent.
That risk agent is where the real commercial value is. Its job isn't to write the contract. It's to scrutinize the drafted text, specifically for liabilities, for exposure, for unfavorable clauses, or regulatory noncompliance in a specific jurisdiction.
So it turns the AI from just a writer into a regulatory guardian.
Exactly. It allows a business to automatically generate and vet complex agreements without human legal oversight until the absolute final signature stage. That drastically speeds up transaction cycles.
And what about strategy? R.1.4 litigation strategy is fascinating. It's not about documents, it's about tactical thinking. It uses 3 agents: case strength analyzer, precedent finder, and strategy planner.
This is essentially an automated litigation consultant. The case strength analyzer takes the raw data and assesses historical win rates for similar cases. The precedent finder grounds that analysis in specific, verifiable case law. And then the strategy planner recommends a path forward: settle, mediate, or go to trial, along with suggested tactical arguments.
It's automating the high-level, data-driven decision-making that's usually reserved for senior partners.
That's the goal.
And finally, R.1.5, evidence management. In any complex case, just managing thousands of documents is an immense burden.
This system solves that document discovery bottleneck. It has 4 agents: document classification, evidence table creation, a relevance agent, and a QC agent. It processes and categorizes incoming evidence, emails, invoices, whatever, and automatically builds those essential evidence charts you need for trial prep.
And the relevance agent highlights the smoking guns.
It highlights documents that directly support or refute the core legal arguments. This saves hundreds, if not thousands, of junior associate hours. It's clear that in the legal world, these ecosystems break down massive tasks into defensible, quality-controlled stages.
So if we connect this to the bigger picture, the education sector seems just as right for these systems, but maybe for different reasons. Law is about rigor and procedure, but education. It requires standardized, repeatable, scalable steps.
Exactly. For curriculum delivery, for instruction, for school management, the R.2 systems in the blueprint show this transition from, a generic AI tutor to a highly structured AI school management system.
And the centerpiece here is R.2.1, the AI digital school multi-agent system. It uses 6 agents, and the purpose listed is simply run a complete digital school.
I have to ask, is that ambition realistic? Or is it more of a technical statement of scope?
That's a crucial question.
Well,
It's not replacing the physical school building, of course,
yeah.
but it is automating the entire functional life cycle of the student experience. The agent roles really show this comprehensive coverage. So you have the curriculum agent setting the learning goals, the lesson plan agent structuring the content,
And the teaching agent actually delivering the instruction, managing the dialogue with the student in real time.
That's the core instructional loop. But the system goes much further into administration and communication, which is where you get the real scale.
Exactly. After the instruction, the assessment agent handles the testing and grading based on metrics defined by the curriculum agent. Then, the progress tracking agent monitors that student's performance over time, identifies knowledge gaps, and suggests personalized adjustments.
And the final agent closes the loop with the outside world, the parent communication agent.
Yes, and that's huge. That agent handles external reporting. It synthesizes all this complex performance data into simple, actionable updates for parents. It manages automated communication flows like permission slip reminders or scheduling virtual check-ins.
So the implication is, well, it's enormous. This system manages the entire student experience, from content design to delivery, evaluation, and external updates.
And the outputs reflect that. You get weekly lessons, dynamically generated exams, progress cards, and formalized parent communications. It's the administrative and pedagogical backbone of an institution, automated.
Let's dig into some of the other education systems because they focus more on content creation and student support. They show how you break down that instructional design pipeline.
For sure. Take R2.3, the video lecture system. It uses 5 agents, and its purpose is to convert any topic into a complete professional-grade video lesson.
So it's a production pipeline.
A highly efficient one that mirrors a traditional media team. You start with the fundamentals. The research agent collects the facts. The script agent formats them into a conversational flow. Then it's immediately followed by the diagram agent.
Which is essential because you need visuals for video learning.
Right. And that agent has to generate prompts for external tools, generative visual tools, to create the supporting graphics and animations for the video.
Then it gets even more specific to media production. There's a quiz agent for interactive assessments and this very specific teacher voiceover note agent. That one sounds critical for making the output feel professional.
It is absolutely crucial for a polished output. The teacher voiceover note agent's job is to generate specific instructions for a human voiceover artist or a high-end text-to-speech model. Things like pacing cues, where to put inflection, which words to emphasize, where to pause.
So make sure the delivery is engaging and authoritative. It moves it beyond just robotic text-to-speech.
Into high-retention media content, exactly.
Switching gears to student support, R.2.4 is the student mentoring system. It uses 3 agents. You have the predictable study plan agent and the weakness detector agent, which are data-driven. But then there's the motivation and coaching agent. That feels like a complex cognitive leap for an AI.
This is a fascinating move beyond pure data into psychological and behavioral support. The motivation and coaching agent is designed to apply principles from behavioral science like gamification, positive reinforcement, goal setting, to encourage consistent study habits.
How does it functionally operate, though? Is it monitoring the student's tone or just their performance data?
It's primarily operating on the data from the weakness detector. So a student consistently skips a certain type of problem or their engagement drops, the coaching agent intervenes, but not with a simple reminder.
Right.
It intervenes with a motivational message tailored to the student's personality profile, encouraging resilience or linking that current struggle to their bigger career goals. It translates the data into emotionally resonant communication.
That system really shows AI moving towards replicating the emotional and motivational aspects of teaching, not just the content delivery.
And the remaining 2 systems, R.2.2 exam management and R.2.5 online course creation, just reinforce that theme of structured, scalable curriculum logistics. One handles the entire testing cycle, the other handles the entire online course build pipeline, from module design to a final QC agent.
So in education, it's about standardizing high-quality instruction and managing the complex logistical architecture needed to deliver it at a massive scale.
Precisely.
Okay, so now we shift gears from learning and law to monetization and growth. This is the engine room of the digital economy. R.3 covers 5 distinct business and startup systems.
Right, and the business category represents systems with really clear, quantifiable metrics for success. Launching a product, securing a lead, hiring someone. This makes them ideal for measuring and optimizing AI performance.
Let's start with what might be the most ambitious system in the entire blueprint. R.3.1, the AI startup launch system. 6 agents with the explicit purpose of launching a startup from zero to pitch deck.
It's automating early-stage entrepreneurship.
It seems like it.
It's a remarkable demonstration of how you apply sequential agent specialization to creative and strategic development. The whole workflow is basically a digitized business plan in action.
So the first 2 agents, the market research agent and the problem solution agent, are tasked with intellectual rigor, validating the idea, identifying the target audience, analyzing competitors.
Defining the core value proposition. This is the intellectual property phase, which normally takes months of human effort.
Then that validated concept moves to the business model agent, which defines revenue streams, costs, pricing, and then a branding agent.
And those 2 have to work in a tight, iterative feedback loop. The brand has to support the model, and the model has to support the brand.
And the final two agents are focused on execution and getting funding. The pitch deck agent synthesizes everything into an investor-ready presentation. And critically, the financial projection agent generates the revenue forecasts and runway calculations.
This system automates the foundational documents you need to secure seed funding. The difficult, time-consuming work that trips up first-time founders or forces them to hire expensive consultants. It's now standardized, structured, and rapidly executable.
It's like a digital co-founder that handles all the paperwork and strategic documentation.
In a way, yes.
An immense value proposition. So what about ongoing operations? The other four systems automate specific departments.
Right. Take R.3.2, the digital marketing multi-agent system. It has 5 agents: strategy, content calendar, copywriting, graphic design, and analytics. This one highlights the absolute necessity of integrating multimodal capabilities.
How does that multimodal aspect work here?
It's the inclusion of the graphic design agent and the copywriting agent working in tandem. The system's output isn't just a text document, it's executable creative assets. The copywriting agent generates the headline, and the graphic design agent uses that headline, the brand guidelines, and external tools like Midjourney or DALL-E to produce the actual visual ad.
So the output is a ready-to-publish campaign, not just a plan.
Exactly.
And moving down the sales funnel, R.3.3 is sales automation, lead qualification, sales email, follow-up, and this crucial conversion QC agent.
That conversion QC agent is the closure mechanism. Its role is to ensure that the proposed deal aligns perfectly with the client's validated needs. It standardizes the handoff from sales to fulfillment. It's a gatekeeper to prevent closing deals that are based on unrealistic promises.
We also see a complete HR lifecycle automated in R.3.4, the HR department multi-agent system. 5 agents covering the entire employee journey: job description, candidate screening, interview questions, onboarding, and performance review.
This effectively takes the administrative and procedural burden off HR professionals, so they can focus on high-touch, employee-centric work. It turns the core functions of HR into a standardized, auditable, and compliant process.
And finally, R.3.5, business operations, uses 4 high-level governance agents: SOP creator, workflow builder, automation agent, and KPI monitoring agent. These agents don't do the work. They structure it.
This system is focused on the meta process, how the business governs itself. The SOP creator defines how work should be done. The automation agent seeks opportunities to implement that. And most importantly, the KPI monitoring agent provides continuous real-time feedback on whether those new processes are actually meeting the business's goals.
It governs the entire operational efficiency feedback loop. It's remarkable how these ecosystems transform huge department functions into executable, repeatable workflows.
Now we need to cover the remaining systems a bit more quickly. They highlight unique value propositions in niche, high-value fields. These often handle the most complex inputs or require the highest degree of safety and rigor.
Let's start with R.4, medical and health systems. Medical data is not only complex, but incredibly sensitive.
Indeed. And R.4.1, the patient health interpretation agent team, focuses on simplifying that complex data for the patient. It starts with a medical report OCR agent, which is crucial for handling scanned documents or handwriting. Then an explanation agent translates the medical jargon into plain language.
But then you have the 2 critical safety agents, the red flag detection agent and the question for doctor agent.
The red flag agent identifies urgent health indicators, but the question for doctor agent is a real breakthrough in patient empowerment. It synthesizes the complex report and any red flags into a concise, structured list of relevant questions for the patient to ask their physician.
So it prepares the patient for the 15 minutes they actually have with the human expert, making sure they cover the most crucial points.
Exactly. It's a high-fidelity filter. It improves the quality of the human-to-human interaction by grounding it in structured data. The other 2 systems here cover daily health management and medical research summarization, both with a heavy focus on that patient-friendly explanation.
Okay, moving to R.5, multimodal, vision, and RGA systems. This is getting into the technical core of modern data, where information isn't just in a text file.
Right. R.5.1 multimodal evidence analysis is built to handle diverse input types. Think of a massive unstructured evidence dump. You have an image OCR agent, an audio transcription agent, and a video frame agent.
So these input agents are doing the heavy lifting before the language model even sees the data. They're standardizing it.
Precisely. Their core job is to convert pixels, waveforms, and image text into a clean, standardized textual format that the downstream agents can then analyze. It solves a huge input bottleneck.
And R.5.2 is all about retrieval augmented generation, or RH. This is the architectural solution for grounding AI answers in verifiable knowledge.
The ORAG knowledge engine is a four-agent sequence that defines the entire retrieval pipeline. Chunking agent, embedding agent, retrieval agent, and finally, the grounded answer agent.
Okay, break that down for us. What exactly is the chunking agent doing in plain English?
Its sole job is to break down massive documents, manuals, research papers into small, discrete, manageable blocks of text, maybe 500 to 1,000 words each. This is crucial because smaller chunks lead to more precise retrieval later.
And the embedding agent.
It uses a specialized model to convert those text chunks into numerical vectors. These vectors are then stored in a vector database, creating a kind of semantic index or map of the information.
So the retrieval agent, when you ask it a question, isn't just doing a keyword search. It's querying that vector database to find the chunks that are semantically closest to the question you asked.
That is the core mechanism. It retrieves, say, the top 5 most relevant chunks of text. Only those verified, retrieved chunks of information are then passed to the final grounded answer agent, which is constrained by its prompt to formulate a response only using the text provided in those chunks.
That's the architectural solution to the hallucination problem. It forces the AI to cite its verified sources.
It does. It confirms that true reliability in AI requires a technical team of agents, not just a single clever prompt.
Next up, R.6, content creation systems, built for scalable creative output.
Right. R.6.1, the YouTube Content Factory, uses 6 agents to automate the entire video production pipeline, from topic research and scripting all the way to SEO and having a publication agent.
And it has that thumbnail agent again, which has to integrate with visual tools.
Exactly. And it also has an editing notes agent, which is critical. It transforms the raw script into time-stamped instructions for a human or an automated video editor, specifying cuts, B-roll, music cues.
Now, the largest team in this entire blueprint is R.6.2, the book-writing multi-agent system. It needs 7 agents. Why 7? That seems like overkill.
Because writing a high-quality long-form narrative requires multiple layers of review, structural consistency, and style development that one agent just can't maintain over hundreds of pages. It starts with structure, a TOC agent and a research agent. Then the core writing is done by the chapter writer.
But the unique agents here are the ones dedicated purely to style and quality. There's a language polisher and a storytelling agent.
The language polisher focuses on grammar, tone, and making sure the prose isn't monotonous. But the storytelling agent, that's the system's internal editor-in-chief.
How does an AI enforce narrative flow? What does that even look like?
It doesn't just correct spelling, it checks against global narrative rules. For instance, it ensures a character's motivation in Chapter 12 aligns with the emotional arc set up in Chapter 1. It might flag an inconsistency like, this character just used technology that the research agent established wasn't invented until 20 years later. Or it might provide instructions to the chapter writer, like, increase the internal monologue here to slow the pace, or ensure this chapter's cliffhanger aligns with the structure dictated by the TOC agent for a 5-book series.
It sounds like this system automates the intellectual, stylistic, and quality control functions of an entire publishing house.
And then you have the final checks, an editor agent for big structural changes, and a proofreading agent for surface errors. It's a full literary team in a box.
And finally, R.7, government policy and public service systems. These deal with public trust and accountability.
So they need extremely high standards. R.7.1, the public service delivery system, uses 4 agents to standardize the interaction between citizens and government: complaint intake, verification, solution drafting, and citizen communication.
This standardizes the response to citizens, ensuring fairness and speed, and minimizing the impact of human bureaucratic inconsistency.
And R.7.2, policy drafting, needs 5 agents to ensure legislative rigor: research, risk agent, drafting review, and a comparative law agent.
The comparative law agent is the key differentiator here. What's its role?
It's arguably the most valuable agent for good governance. Its job is to analyze existing policies and legislation from other jurisdictions, states, provinces, other nations that have already tackled the same policy problem. It benchmarks the proposed policy against global best practices.
So it helps policymakers leapfrog the learning curve by integrating global experience automatically.
Exactly. And when you couple that with the risk agent, which flags potential legal challenges or unintended social consequences, this system elevates policy drafting from simple proposal generation to rigorous, evidence-based analysis. It makes bad policy much harder to implement by automating the oversight.
So what does this all mean? Across all 20 of these systems, from high court briefs to startup launches, medical interpretation to policy drafting, the recurring theme is crystal clear. It's the absolute necessity of specialization, sequencing, and quality control.
That is the core architectural takeaway for anyone who wants to build with AI. No single monolithic AI model can perform these complex, high-stakes tasks reliably. They require teams of agents, each with a constrained context and structured communication rules,
The complexity of the job has to be partitioned into simple, reliable steps.
and then assigned to specialized agents that feed their output sequentially to the next step, which often includes a critical review or QC step.
For you, the learner, this is more than just an interesting inventory of futuristic systems. This blueprint is proof that future AI implementation isn't about finding a single powerful prompt. It's about designing and engineering sophisticated internal workflows.
That's right. If you can meticulously define the procedural steps of a complex knowledge job, if you can draw the org chart, you can build the structured agent team to automate it.
This blueprint lays out 20 production-ready systems. Blueprints ready to be implemented in platforms like ChatGPT, Teams, or AutoGen. We've seen the plans for an entire HR department, a video production factory, a legal appeals brief.
These are not proofs of concept, they are organizational replacements.
So if the knowledge and labor for these highly complex white-collar tasks can be reliably partitioned and automated by a multi-agent ecosystem that's designed for self-correction, then the definition of a safe human job is fundamentally shifting.
That is the final provocative thought. If the blueprint for an entire professional function is standardized and executable by a team of AIs, what complex human job is truly safe from being broken down into its component parts and automated next? The future of professional work hinges on the ability to define, partition, and structure the workflow.
It's something to mull over as you think about how you structure your own work and where true human value will reside in the next few years. Thank you for sharing these incredible sources with us. That was a serious deep dive into the architecture of tomorrow's digital workforce.
Our pleasure.
We'll catch you next time.